Cotangent? Well, I need. Yeah, I got cotangents and tangents indeed. Oh, she's a graphing way over town, and I need some help. Welcome to 4-6. Here we're going to be sketching other graphs as opposed to sines and cosines. We are going to graph the reciprocals, secants and cosecants, for those of you who don't remember what those are. Remember, secant is just abbreviated SEC of t, and cosecant would be CSC of t. So cosecant's the reciprocal of sine, secant's the reciprocal of cosine. Those are going to be two of the easier graphs to do. They're not going to take a whole lot of thinking. Tangent and cotangent graphs may take a little more thinking on your part. So let's move on to some thinking here. Alright, so what we learned in 4.5 was that sine and cosine functions have a period of 2 pi. So that means the reciprocals, cosecant and secant, would also have the same period. However, tangent and cotangent just not going to be as nice. They have periods that are a length of pi. And we'll find out here in a few minutes why that is. But it all comes down to having undefined values, those dang fractions. So let's look how we sketch a graph of a tangent. First, let's look at what it looks like. It looks just kind of like a little sloping action going on here. It almost looks like your x to the third graph is what it looks like, but you have an asymptote here at that shouldn't be over there. At negative pi over 2, it has another asymptote at pi over 2. So if you think about the distance between negative pi over 2 and pi over 2, that is pi, which would mean that one period of tangent would be from negative pi over 2 to pi over 2 and would follow this little curve. Over here you'd go from pi over 2, this is pi, and then you'd be at 3 pi over 2 right here. And then this would be where your asymptote would be over here, and this graph would keep going up. And the tangent graph just keeps, how do you want to say, not recycling, but every cycle it just keeps repeating after and after each time there. So when we look at these bullet points here, since we have a period of pi, then one period is going to be between the interval of negative pi over 2 to pi over 2. So if you remember, tangent of pi over 2 and tangent of negative pi over 2 are undefined. If you think about the ordered pair at pi over 2, that's the ordered pair of 0, 1. So the tangent of pi over 2, well, that is going to be your y value over your x. So that would give you a 1 over 0, which is undefined. So that's why you're going to have an asymptote here at pi over 2. Same thing for negative pi over 2. Negative pi over 2, remember coterminal angles is the same thing as 3 pi over 2. And at 3 pi over 2, your interval or your ordered pair is 0, -1. So this would be a -1 over 0, which is still undefined. So that's how you get your asymptotes for tangent. Easiest way to do this is to graph your vertical asymptotes first. Okay, draw those first. Second thing you want to do is find your x-intercept halfway between, and then you can make a table for your other values. I'm only going to require 2 other values. Okay, so I'm really going to require 2 other values. Basically, what's going to happen if you draw in your asymptote at negative pi over 2 and at pi over 2, you find your center. Well, halfway between 0 and pi over 2 would be pi over 4. So you're going to make a table of values, and one of your values is going to be, for your theta, is going to end up being pi over 4. And so you're going to plug in pi over 4, and you're going to find out that it is a positive 1. Then you may choose between 0 and negative pi over 2. Well, negative pi over 4 would be another great value to put in for theta. And that means that your tangent at negative pi over 4 would be a -1. So you get this ordered pair down here. So then what you do is you just extend your line through these points, make it nice and curvy, don't make it straight, but this line will keep extending as you go up to the right and get closer and closer and closer to your asymptote. As you go left, this goes down and goes left, closer and closer to your asymptote. So let's look at our first example, and we want to graph this function. So remember, the first thing we said to do is you need to put in your asymptotes. We have an asymptote here at negative pi over 2, and you have one at positive pi over 2. And what we'll do is we'll graph 2 cycles here. So your first is drawing your asymptotes. Second step, we want to draw in your halfway point. Halfway x-intercept. Halfway x-intercept. So halfway in between here would be at 0. There's that pretty little value. And then what we want to do is we're going to choose a point halfway in between each of these. So we're going to plug in a pi over 2 and a negative pi over 2. And we're going to plug them into our equation. So plug in pi over 4 and negative pi over 4 for x. So if we solve the tangent, actually we're not solving the tangent, we're saying y is equal to 2 times the tangent of pi over 4. And if we think back a couple days ago, tangent of pi over 4, well, pi over 4 is just the ordered pair of radical 2 over 2, comma, radical 2 over 2. So if we take our y over our x, your radical 2 over 2 divided by radical 2 over 2, that's just going to be a 1. So we are going to take a 2 out front times 1. And that is going to give us a positive 2. So we're going to have a point over here at pi over 4 up 2. Here's the dot. So what we've done is we have vertically stretched our normal tangent function. Then we're going to find y equals 2 times the tangent of negative pi over 4. And if you remember, at negative pi over 4, your ordered pair is just radical 2 over 2, comma, negative radical 2 over 2. So your ordered pair here then ends up being, when you take a y over an x, gives you a negative 1. So we're going to plug in negative 1 times 2, and we get negative 2. So you go back to negative pi over 4 down to, here is your point. So we're going to connect these dots, stretch it up, and gets closer to your asymptote. This goes down, gets closer and closer to your asymptote. Perfect. So if you want to draw more than one cycle for each of these graphs, what we can do is we can just extend our asymptote over here to 3 pi over 2, draw another one in here, put a dot in the center at pi, and then halfway between pi and 3 pi over 2 we would go up 2 and put a dot. Halfway between pi over 2 and pi we'd put a dot here, and then we would just extend this line. Whoop, looks like I'm going to have to make my dot bigger. This goes down over this direction. And then you could just keep repeating that left and right as much as you want. So that's your introduction and your first example of how to graph a sine function. Or not sine function. Who am I? What am I doing? I don't even know who I am. Tangent function. Y equals 2 tangent of x. So let's look at maybe 1b. Oh god, negative tangent of x. Well, negative. That just means you reflect over the x-axis. So if you reflect over the x-axis, we're still going to have your asymptotes in the same spots. Negative pi over 2, not the color I wanted. At negative pi over 2, like so. You're going to have one at pi over 2, you put your dot in the middle, and remember, instead of going up and to the right, we're actually going to be we should be coming down and to the left. So we need to plug in a value here at negative pi over 4 and pi over 4. So let's find y equals the negative tangent of pi over 4. And from the previous problem, we know the tangent of pi over 4 is just 1. So we're going to have equal to a negative 1. So at pi over 4, we're going to go down 1. So over to the right, pi over 4, down 1. Here's your dot. Then we want to find y equals the negative tangent of negative pi over 4. So we know tangent of negative pi over 4 from the previous problem is just a negative 1. So that's going to be negative 1, which is a 1. So back pi over 4, up 1, put a dot. Here's your Purdy graph coming down from the left, going through the first dot, going through the second dot, third dot here. Almost hit the asymptote, but not quite. And then you could repeat that both to the left and to the right, if the directions say, or if you just feel the need to. That's example 1, folks.